I'm Julian, and I'm going to talk about the past 10 years of building open source standards from Parquet to Arrow to OpenLineage. So I split that in three parts, and every time I have like a few lessons learned about open source, what gets keep the community going, and so on. And so it's going to be a little bit like the story and the lessons learned, and that's the important takeaway from the talk. So first, the birth of Parquet. So any of you remember Apache Pig? Kind of like maybe a bit the old technology nowadays has been replaced by Spark mostly for those use cases. But it was my first contribution to an open source project, and I got the opportunity to go all through the life cycle of going from user to contributor to committer to PMC member, and even being the PMC chair for a year on that project, which was really a learning experience in the Apache Foundation of getting this. So it's like from first using it to contributing. It's also around the time that the Dremel paper came out, around 2010, and like the first, reading papers as an engineer, like figuring out what's going on in the industry. So through that, that's how I got my first job. My next job, like joining Twitter, like there was a big community around Pig at the time between Netflix, LinkedIn, Twitter, Yahoo. And so at the time, we had Hadoop, which was, can store a lot of data, can process a lot of data, but very high latency, right? You launch your query, you go get coffee, and you come back and get the result. And it's relatively cheap for the volume it can store. And we also had Vertica, which is more traditional distributed data warehouse, which was a much better interactive experience. You can get more interactive queries, but at the time it was not as scalable and much more expensive and not as stable as well as Hadoop, like depending how you look at it. So there was kind of some trade-off. There was always this chicken and egg problem of what data goes into Vertica because we can't put all the data in it compared to Hadoop, had a lot more data, but what's not as convenient to use. So the big question is, how can we make Hadoop more like Vertica? And so if you look at Hadoop, there's like those two components. There's MapReduce, where you can like process a lot of the data in a fairly simple parallel model, and there's a distributed file system underneath when you store files. In Vertica, you have this distributed query engine that is on top of a columnar storage. So slightly different abstraction. How is the columnar storage different from this distributed file system, and how can we make Hadoop more like Vertica? And so that's where, at the time at Twitter, we had this very nice paper reading group where we started reading about papers, like what's the state of the art. So Vertica already had, there was the original CStore paper and the Vertica paper that explained how that works, what's columnar storage. Of course, I reread the Dremel paper at the time, and there was this MonetDB paper as well, which is like foundational on the vectorized execution and how you make those very fast, massively parallel engines. So, that got thinking about how we can do the processing on top of Hadoop better, and thinking about what is columnar storage, how the columnar layout works, right? And of course, when you think about a table, is this two-dimensional thing, right? Like you have rows and column. But when it's stored on disk, it is like just putting bytes after one another. So if you have a row layout, you're actually interleaving data from different columns. And if you're selecting a subset of the columns, you're going to have to read a few bytes, skip a few bytes, read a few bytes, skip a few bytes. And it's kind of interleaved. It doesn't compress very well. When in a column layout, the big difference is you put the entire column at a time, right? And so if you're selecting a few columns, you can much more efficiently access it, and you can also much more efficiently encode the data, because if you have a bunch of integers in a row, you can compact that much better than if you interleave different data types of different columns. So that's kind of the underlying tricks to go quickly. And so from this, we started the Red Elm project, which has this intersection of looking at the Dremel paper, looking at existing file formats that were trying to do kind of columnar things in this ecosystem, and the schema system we were having using Thrift and Pig at the time. And so that got to starting this project. So I just dug out this first commit from 2012, so a little more than 10 years ago now. And Red Elm was an anagram. And so that's like to say that it was pretty ambitious at the time, right? Like Red Elm was an anagram of Dremel, And the idea is like, oh, we're going to do the columnar storage, we're going to do the query execution, all of it, and it's going to be great. And like a bit ambitious. But very quickly, I realized, okay, I cannot build like on my own, like this proprietary thing. Even the file format, I didn't want to build a proprietary file format that would have to integrate with everything, and there was like way too much work. So started like, I was at Twitter at the time, right? Starting like talking about it, finding like-minded people, like, look, it looks like this is the need, like we can't possibly be the only one thinking that. And so, started saying, who else wants to work on the columnar file format and really solve that and make, the processing on top of this distributed file system better? And the reason I know there's an error there is because I used the examples in the Dremel paper as a unit test in my code and didn't pass. It was like, what's going on? I must have a bug somewhere. Well, there's a bug in the paper, which is cool. And that's where I joined forces with the Impala team. So the Impala team at Cloudera was also prototyping a file format. And they were already building the query engine. So it was like, great, we don't have to reinvent that piece anymore. There's already someone building this. And so we joined forces and we found a name. So now we were scoping the project to just the file format, found a good name for it, and focus on this better compressed, optimized for data retrieval, compatible with the Hadoop ecosystem, Parquet format. So that was the beginning of it. And so on that, I put a little timeline on what the adoption looks like, right from the first commit to getting together in 2013, and like others like starting talking about this, other joining, like Criteo added the Hive support. On my end, I was doing the Pig and Swift and a few other things, the integration. The Impala team was building Impala on top, like SQL and Hadoop, using native code generation. And then quickly we start seeing adoption, like the Apache Drill was another SQL and Hadoop project. Netflix also adopted Parquet for their internal storage, and they started adding Presto support at the time. And quickly you see the speed of the project accelerating and getting more adoption. Eventually, Spark SQL built on top of Parquet as their storage because it made sense, right? We all needed this format, and so kind of made sense. And from them, nowadays it's kind of everywhere. All the major data warehouses support Parquet. So I kind of skipping after 2015 and reaching this inflection point, and then like nowadays if I disappear, Parquet will go on, right? Like so it kind of takes a life of its own, and that's like the magic of open source. So some of the lessons learned along the way. So the first thing is really to make this successful. Every contributor becomes a stakeholder. Right? It's not just they use the project, right? Or like they report a bug or something, right? No, now you're part of the project. You get a voice in this. When Netflix starting adopted, they had committers. They became like really part of owning the project and having a voice in the decision-making process. And now we make community really own the project and be able to drive this and being part of this, right? So it's really about making everything, have skin in the game and own part of it. A second lesson learned is this snowball effect, right? So you can see it's not just you keep pushing rock up a hill or something, right? As it's accelerating, it's gaining weight, it's gaining momentum, it's going faster. And the faster it goes, the faster it accelerates. And then really you see this exponential growth curve, and it's really happening, right? Like it's not like you need to convince everyone just at once, right? It really grows and it takes a life of its own until it reaches escape velocity, and then it goes and does its thing on its own. The other interesting about open source is there are very different definitions of open source. And I think they're all very fine as long as you understand, right, how each project works and what's the governance. So the first very basic definition of open source is the code is available. But the code can be available, you can be able to read the code, and you're not allowed to use it, right? The fact that you can read the code doesn't give you any right to use it. So that's the first thing is the license, right? Open source licenses give you the right to use it. So things like Apache license or MIT licenses are very permissive. The only thing they require, and if you change the code, they reuse it, you have to say this explicitly and give credits to the original project. Other licenses will have constraints of if you have derived work from that, you need to reuse the same license like GPL. And so that's the first thing, right? What can you do with this code? Second is governance, right? Because you can have code that is open source, you're free to use it or look at it, but you cannot contribute to it, or you like who's deciding how the code evolves, who accepts changes to the code. So that's usually an open source project has a very clear governance on how decisions are made, how you can contribute to it, and contribute is the thing, but who accepts contributions as well, and understanding that. And the last aspects is foundations, right? Like when you have governance on a project, someone owns it. Someone decides what the governance is, and someone decides how it changes, how the license of the code changes. So a foundation, and it depends what foundation, but the two big foundations I have in mind that we're used to see is on one end the Apache Foundation, and the other one the Linux Foundation, and in particular the LFAI and Data, which is the sub-foundation of the Linux Foundation that focuses on data, are a way to say there's this independent, neutral third party that is responsible, that owns the project, and that makes sure that nobody can take control of it, and make sure then, for example, you can have a commitment that the license is never going to change, and then there's always going to be some overseeing on how governance gets changed, and the project exists independently of any company or any third party owning it. So those elements are really understanding, and it's fine, depending on each project, it's fine if they're owned by a company. It's fine if the governance is restrictive or if the license is more restrictive. It's just something you have to be aware of, right? Like there are different constraints, there are different rules of the games. So don't use an open source project assuming something when it's not, right? But just some of the aspect of, and of course, I think all three of them are very important when you're doing an open source standard and you want adoption and make it part of the industry. But not all projects are like this. So second part of my talk is looking at the Parquet to Arrow evolution, and you notice my timeline on Parquet stopped around 2015, and I'm going to pick up from there and talk a bit about the development of Arrow. So in the Parquet community, there started to be discussions about the need for an in-memory columnar format. And you will say, well, you have an on-disk columnar format, maybe we should use that in memory. But actually, there's very different trade-offs. And if we go back to this MonetDB example, for example, which is talking about vectorization in query engine, there's this need for, like modern processors, they're not just executing one query after the other. There's a notion of pipelines, query instructions execute sequentially. They're split in multiple steps, and there's a lot of cost of branching and not knowing what's coming after. So being able to do the same instruction in a row many times allows the processor to go a lot faster, and also being much more localized in memory is using the cache of the processor a lot faster. So there's a lot of physical characteristic of modern microprocessors that make it so that using columnar representation in memory optimized for fast execution makes those vectorized engine much faster, which this paper talks about. And that's what drives different trade-offs from retrieving from disk versus processing in memory, led to the creation of Arrow. So, like Parquet focuses on the fast disk retrieval, and predicate pushdown, and Arrow focuses on the fast in-memory processing and standard sharing of data across things. So we kicked off the Arrow spec by creating a group in this, leveraging this Parquet community, finding a group of people who actually needed this kind of standardization, kicking off a spec, and starting this project. So what happened is actually there was an existing in-memory representation in the Drill, Apache Drill open source project that was very similar to what the need was. So we started from spinning it off as its own project, and that became the Java implementation for Apache Arrow. and starting the C++ implementation, making the change that came out of that group that discussed how we make this standard for the in-memory representation. And then it's starting kicking off. You see the same adoption curve because there's this common need. And having the Wes McKinney, which I saw started the C++ implementation. He also drove the C++ implementation on the Parquet side. It got in Panda, got adopted in Spark. There was a lot of interest from GPU data sharing as well because they have the similar needs in GPU. And nowadays, same thing. You see this adoption, this acceleration, and it's adopted in all the major warehouses. And a quick note, like DuckDB is a hot thing, I think this year. And it's really like this kind of like use SQLite for OLAP or the local mode for your data warehouse or your big data fits in memory. We had a keynote talking about big data is dead or it fits in memory now. And so you can build on top of your Parquet Arrow data and really create this massively parallel on single machine, and that's very exciting. So it's just like interesting to see the kind of evolution of going from those distributed warehouse back to single machine, very parallel. So we're kind of going full circles here. And so the lessons learned here in that case, so still building like, so in Parquet, we kind of stumbled on the thing, right? Like we kind of, we work together and like much stronger are two companies driving the thing than one. And then, a third company joined and like we're much stronger. And then the project is much more valuable because we collaborate, right? So in Arrow, we kind of bootstrap this. If you're going to want to have this snowball effect, let's start with the snowball as big as possible at the beginning, right? Because if you look at an exponential growth, well, the very beginning of the exponential looks awfully flat, right? And it grows very slowly. So you really want to get to this inflection point as fast as possible, and then things become a lot easier. So it's really about bootstrapping the community with an initial spec and get this going as fast as possible. And second, it's really important to find like-minded people who will drive the vision. And because nowadays you say, Parquet is everywhere. So how do you convince everyone? Well, you don't start by trying to convince everyone. You start by trying to find the people who get it, who see not just that that it is successful to use it, but they know that because they're going to use it, it's going to be successful, right? You start with a few visionaries. So Wes, I'm talking about you, and Ryan Blue, and a few others. Sorry if I'm forgetting people. But really kind of drive the thing initially, and that momentum, it convinces the early adopters, and then the early adopters, they adopt it, and that more momentum, that convinces the mainstream, and then eventually everybody uses it. So it's really important to, when you grow this, you don't have to worry about convincing everyone, you just need to find the people you're going to work with, and we're going to build this together. And someone was telling me, you're doing open source the right way, like kind of implied the hard way, right? Kind of like we work with people, like people are so hard to work with, it's true. But, I kind of cheating in there, right? Because some people will tell you it's not about the destination, it's about the journey, right? Like I'm doing it the right way, the hard way or the right way, but the cheating part is I'm actually enjoying this. Like it's very rewarding to work with those people, build things together, and really to build this momentum and see it going. And, in some way, I'm telling you, you have to do this so that you achieve your goal. But really, I'm doing this because I enjoy the process. And eventually, I achieve the goals, which is, the cherry on top. But you really have to enjoy it and like collaborating. And you really get to work with incredible people that, would not all work in the same company otherwise anyway. And so it's great to be able to collaborate in that setup. So onwards, it's kind of the next thing I've been working on is the OpenLineage spec we started a few years ago. And again, like this timeline, the Arrow timeline has stopped like a few years ago. And then it kind of got escape velocity as well. And I'm going to restart from where I stopped. And so similarly, there's a common need for lineage metadata, like understanding what are all the transformations that are happening, right? So typically, inside a team, people have very good understanding of what their practices are in the team, what data they read, how they transform it, what are their best practices, what they produce. But outside of it, well, those data sets we're reading from, where are they coming from? Who produces them? And who do those people depend on? Like, all of this is very opaque. Or like, I'm producing this data set, but who's consuming it? What are they doing with it? Is it like, oh, I just built this over a weekend and it was a experiment, and now it's being depended on for the model that is in production. That's the key revenue driver for the company or something. And you're like, oh my God, I never signed up for this. So happens all the time. So there's lots of opacity of how people depend on each other, and it's a problem, right? Because data needs to be reliable, and if you don't understand what you're depending on, it's a problem. And so I've been repurposing, there's this Maslow's hierarchy of needs, which is before you reach happiness, before you need to be safe, you need to be fed, you need to, a lot of basic vital needs before you can actually reach, happiness and self-realization of becoming the best version of yourself. Same thing in data, right? Before you can actually get any value out of it, often we're head underwater, like, oh, is the data available? Is it up to date? Is it correct? And once you manage to do all those things, then you say, okay, now we kind of look at optimize our business or find new opportunities and leverage this data and build new products around it. And a lot of the time we get stuck in the bottom layer, which doesn't bring value, but brings a lot of pain. So that's what led us to start the Marquez project. So at the time, we're at WeWork, building the data platform there and like the big growth phase of the company. And the big missing piece in that data ecosystem was building that map of all the transformation, all the data set, and build a map of everything, how your data gets from one place end to end, and understand how people depend on each other. And so, that's how we, after creating Marquez and some turmoil at the company I was working at, we decided to start Datakin, which focused on data observability and really focused like, does the data show up? Is it correct? Does it show up in time? And is it correct? And now part of Astronomer, which is really this mission of delivering data through orchestration and making sure all your job runs all the time and giving you the tools to understand why something's broken when it's your fault and someone changed the schema or something. And so we started Marquez as this repository for everything, but as we were thinking about it, really the most reusable part of it and the problem for the industry was the collection of lineage, not necessarily the storage, right? You have multiple tools and product that store lineage and represent it and analyze it and provide tooling around it. But extracting the lineage of everything that's happening, all your SQL queries, all your Spark jobs, all your DBT jobs, and all of those things, it's really opaque, all the ETLs and BI tools. It's really opaque how you get the lineage, and it's constant pain to manage this. So that led us to start OpenLineage as a similar idea, right? There's a common way for all those metadata storage, like governance tools, data observability tools, to collect this metadata and understand lineage and avoid this n-square problem, like all the data catalog. And I put examples here in the open source because that's kind of what I've been leaning towards. But of course, that includes also proprietary solutions, commercial tools have the same problem of having to go on all those things that transform data and figure out what they're doing. And so instead of having this lot of duplication, of lots of communication, if you have a standard representation, it simplifies a lot the problem because now everybody speaks the same language. Same idea as for Parquet, how your data is interoperable between the various tools you're using or warehouses. And now you have a common way of speaking, and it simplifies a lot getting the lineage and metadata available. So OpenLineage is a spec, and it starts with the spec, and of course there are integrations, and you have producers, whether they're transformation of data quality tools. Again, I put some examples of what's covered, like some very popular ways of doing those things. You can collect the OpenLineage events that describe the runs of those transformations and use them for various use cases. And it's not an either or. You don't have to pick one metadata system that solve all your problems. You can start having this metadata bus that sends OpenLineage event and use multiple tools depending if people care more about data governance or data reliability or data quality. And so I'll restart my little timeline. So end of 2019, Marcus joined the LFAI Data, which is the sister foundation to the CNCF. And there's a lot of parallels, right? Like in the CNCF, you have Kubernetes, you have OpenTelemetry, which is observability for services. And the LFAI Data, you have a lot of AI projects, some metadata projects, like Amundsen is there, and there's Marquez, and OpenLineage was spun off out of Marquez, and we did a similar thing then with Arrow. We reached out to a bunch of people in this open source ecosystem through the connection with Parquet, with Arrow, and all of that, putting them in a room virtually. That was pandemic on Zoom. And then talking about what's the initial spec. How do we represent all the running jobs and make sure we have a common way to represent it? And bootstrapping this with Spark, Airflow, dbt support, the common open source tools, getting some good collaboration with Microsoft, the Edge Area, another open source project. Snowflake, we had a good discussion with Snowflake. There's a Snowflake Labs support for OpenLineage. Manta, which is a lineage extractor company, also supports OpenLineage now, and a lot of building momentum like this. And now we're present day, right? And you've seen on my timelines, it's going to take another couple of years, and then we expect to reach this escape velocity and keep growing. And OpenLineage and now graduated out of the sandbox in the LFAI Data, and we keep building more relationship and more value because that's how the project becomes more valuable for everyone. And so if you think of the model and just putting some elements here for, the good thing about OpenLineage is we can all contribute to make the coverage better, right? So the model is fairly simple. You have this notion of job, right? A job is a recurring thing that runs every hour or every day. And the typical transformation you might be running that materialize a table, right? And the run is this notion of identifying each run of that particular job. And then it has inputs and outputs that are marked as data sets. So there's this model that uniquely identifies runs, jobs, and data sets so that we can stitch together the lineage and everybody speaks the same language in identifying all data sets in the same way. And then you have this notion of facets, and each facet is an individual piece of metadata that can attach to each of those things. And each of them has a schema that describes this representation. So it gives us a lot of flexibility in representing metadata. So one of the goals was to not build a big monolithic spec where it would take forever to agree on, but to have this very simple core model that describes the lineage and recurring things and capturing what's running, a bit like we capture tracing in OpenTelemetry, but the model is different. And then around that, the community can start defining a lot of those facets. Like on the data set, you may care about what's the schema of the data set, right? So we're capturing the schema at the time the job is running. So if the schema has changed from one run to the next, you know exactly what's changed, right? And you can start tracking the differences and when they happen. You can keep track of statistics, how many rows were written by this particular run, how many nulls were in this column at that time, and something is very valuable for troubleshooting problems afterwards. On the job itself, you could capture what's the version of the code, right? So that the schema has changed, you can tie it back to what was the Git SHA that changed this, and you can troubleshoot and figure out what's going on. On the run, you may have the query profile, how much it costs, right? Like if you run on your favorite data warehouse, each query will have metadata attached to it, like how many billable milliseconds on the cluster you use, how many billable scan of megabytes you use, and keeping that information. So that becomes very useful for various use cases, and it's very flexible in adding various pieces of metadata around that lineage information. And on that, so there's two ways you can add facets. One is through the core spec, right? So if you go on the GitHub project, you have a core spec. Each facet is represented by a JSON schema. And so, of course, they can be contributed. Here, you have all standard things like data quality metrics, schemas, column level lineage, things like that. But it's also very flexible in enabling people to add custom facets if they want. So all you need to do to make a custom facet is to respect some prefix, right? Define a prefix for your project where you're defining custom facets, and publish on the URL the JSON schema for it, and then you can start using it. And that makes it very flexible, because if you want to experiment with something, there's something you don't know yet if it's worthy of putting in the core spec, and you don't know if you have the energy to build consensus around it, you can very much define your own thing, experiment, and then it can be promoted to the core spec later on to make it more useful. So I'll go a little faster because I have a little more time than I expected, but quickly, this is just an example of the Python client on how to define facet, and I'll send you to more resources on how to do this. And if your favorite tool is not yet covered, it's really easy to just add to the tool the description of what were my input, where were my output. And if everybody publishes their lineage in the same way, it's very powerful to be able to have your lineage end to end. And the possibilities are endless. There are a lot of use cases around lineage. Like everybody wants lineage, but then when you dig, they all have a different reason for it. So there's like the data reliability, which we've been focusing on. Does the data show up? Does it show up on time? Is it correct? There's a lot of compliance, GDPR, CCPA, privacy laws. Where is my user private data going? Like, oh, we used to not know, now we need to know, and it's much better that we have to know. A lot of banking regulation, governance, just data cataloging, knowing where the data is coming from, and a lot of that. So I go on the lessons learned quickly on that. That's my most important thing. Someone was telling me, oh, I've done Parquet before, I work on Arrow. I know how to build a community. And it's like, what makes you think you can do it again? And I was like, well, it's not like I build a project and I have some mind trick that I convince everyone to do it, right? It's not how it works at all. The way it works is like, oh, everybody needs that thing. All it needs is someone to help pushing the community, and it's like, let's solve it together. The only way we are going to solve the lineage problem in a sustainable way is if we get together as an industry and we stop like every project reverse engineers every transformation layer, and we keep like running after like, headless ducks and trying to figure out, oh, this has changed, it's broken now and all of that. Let's stop doing this, right? We get together, we solve it together. So the trick is, you build something people need, right? We build it and you're very collaborative, right? And that's what the trick, that's what makes it work. Like everybody needs the thing, and being very open, empowering people is like, no, you're not a user of the project. You're a stakeholder on the project. Now you're part of it, you're part of the decision-making process, and we're building this together. And OpenLineage is designed in a way that we can make all those small decisions independently, right? You don't need everybody to agree on everything. You take the people who care about data quality, you make them define the data quality facet. You take the people who care about governance, you make them define the column level lineage. And that works very well, right? And you just need someone to push along and help the thing, which leads me to my stone soup story. So there's this children's book. It's a guy who comes to a village and is on the town square and starts heating a pot of hot water. He puts a stone at the bottom of it, and people come, he's like, what are you doing? Well, I'm just doing a stone soup, which really is a soup at nothing. It's just heating water, putting nothing in there. And he's saying, but if you want to add your own ingredient to my soup, I'd be happy to add it, right? And we add it, and people come with carrots or leeks, and everybody who adds something makes it better. And like everybody is more incentivized to come, oh, like this soup is better now. I'll come as well, and I want to participate. That's all I'm doing. I'm stirring the pot. I'm telling people, come put your own ingredients. It makes it better. And again, people are saying like, oh, you're boiling the ocean. Well, I'm boiling the ocean, but yeah, wait a minute, because there's a big network effect in there, right? It's not like, oh, it's just like, no, we're 2 people or 3 people and we're boiling the ocean a little faster. The magic happens when the community start talking to each other, right? So at the beginning, I talked to that warehouse, I talked to that data catalog, and, but eventually they start talking to each other. And then they talk to other people. And then I'm not doing the selling. We're all doing the selling. And it all makes sense. No, look, it makes sense. We need this. Let's just like do it together. Let's not wait for it to happen. Like people say, like, why doesn't it exist yet? Well, it just didn't exist because you were not trying to do it, right? So here we are. So just and we're out of time, but quick summary of, people as stakeholders, snowball effect, the open source in different shape and size, like bootstrap it, collaborate. It's about the connection you build along the way. And just find a need and fill it, align incentive, and magic happens. And that's it.